Namaskaram everyone. Welcome back to the 48th episode of our Master Unreal series. And in this episode, we are going to finally have a look at behavior tree. So in this episode, I'm going to show you the entire structure by taking a real world situation. Then we will convert it into Unreal Engine's behavior tree system. And in that process, we will understand how you can migrate the situations or scenarios that you have in your mind or you took from real world, how you can take them into Unreal Engine by using correct features that comes with the AI that is given by Unreal Engine in the behavior tree approach. So if you haven't watched the previous episode where I've shown you what is exactly the programming, I would encourage you to check it out because that will help you a lot in the coming few episodes of AI and NPC. So I highly recommend you check that episode out. I will leave the link in the description and in the card section as well. Okay, so without wasting any time, let's get started. All right, so we are on the presentation now. Let's have a look at it. Let's say there is a person, Alex. There is a set of activities in his life which he do on a daily basis. And here is the list. First, he wakes up in the morning, then he gets ready for the work, then he leave for his work, then he works at office from 9 to 5, let's say. Then once the time is over, he leaves for his home, and once he come at home, he eat and then he sleeps. So this is a very small set of activities which is the lifestyle of this particular person. Now let's see how this is working out. If we focus on each activity, let's start from wake up. To wake up, Alex need to keep track of time. He might also need an alarm which rings at 5 a.m. let's say or 8 a.m. and he wake up. Once he wakes up, he will get ready. Then he will leave for his work. But before leaving for his work, he needs to check if the weather is okay. Can he take his car? Is it working? If everything is good, then he will leave for his work. Then he will work at office where he will check like does he have any meetings. If there are any meetings, he will first attend them, and in middle of that he might also do some work assignments. He will check that all my reports are completed or not. If not, then he will pick some from the backlog. So like this he will have his 9 to 5 routine. He's a developer, let's say. Once the 9 to 5 job is over, he will come back to his home, and again to come back he has to check whether the weather is okay, his car is still in the parking lot waiting for him, and once he come back at home he will sleep. So what can we conclude from this entire example? There is a person Alex and there are four things going on. First is he's using his intellect or his memory. For example, where is the office located? What are the things he has to do once he get to his work? Once he gets to the office, like what are the meetings? Are there any reports? Second thing is a list of activities, and then there is a decision making involved. Like for example, if he wants to leave for work, he has to check whether he can take his car. Is the weather okay? What time is it? Like the normal routine says from 9 to 5. And the last thing is keeping track of surrounding. That means what time is it? What is the weather? So basically the data that is dependent on the external world. So he has to keep track of that surrounding. And whatever is connected with his lifestyle, he has a brain where he organizes stuff for now. So if we translate this into Unreal Engine and to behavior tree specifically, then there is an AI which has a Blackboard which stores the data and you can use it, or the AI can use it. Second, there is a list of tasks that you will define or you will arrange. Third thing are decorators, which is nothing but used for decision making. And then there is something called as services, which keep track of surrounding constantly. All right. So this is the translation from real world to the Unreal Engine's behavior tree system. So for example, you can store information like where is the home, where is the office located, their locations, where is his car, everything that is a data is stored in the Blackboard. Second, the tasks, which are nothing but your activities like what you do in a daily basis as a AI. Third thing, decorators, which are involved in decision making, that helps you to decide whether should I proceed for this activity or for the tasks or not. Based on certain conditions, you follow the tasks. Then the last thing is services, which will be keeping track of the time, what is the weather, so the external things. Now let's translate this into Unreal Engine. We have a starting point, and if I draw a rough diagram, first he wake up, then he get ready, then he leave for his work, then he work at office, then he come back home, then he sleeps. Everything is sequential. Everything is connected and dependent on the previous one. So does the life of Alex looks like a sequence at this moment at least? Let's forget about the cases that can happen. But if we just focus on a positive and a happy path, this is how he lives. So for this, Unreal Engine gives you a sequence node that allows you to execute tasks in a sequential order. So what you will do, you will add the sequence node and all the tasks that you want to get done in step-by-step format, one after another, you will add them in the sequence node. So first it will call wake up. Once it gets completed, it will call back sequence that, okay, I'm done. Then you will go to get ready. Then it will return into true or false based on whether this task is completed or not. But here is the catch. Sequence executes everything in a sequential order, that is from left to right. And if any one of them fails, the process stops. That means it will not go further. So let's say you wake up, then you get ready, and now you are about to do the task, but your decorator or the condition says that the car is broken, or let's say the weather is bad. So this task cannot be completed, or it cannot be started. So it will say false, and sequence will say, oops, the flow is broken. I got a false flag from one of the tasks, and now I will not go further. So that means your sequence will break here right after this task. And then the sequence will go back to root, and then the game is over. And now it will run again, but that is a different thing. The sequence node will stop immediately if a task fails in the list that you have defined like this. Now let's have a look. Does life always run as smooth? Like I mentioned this example, what if a weather got wrong? Maybe you did not wake up because there's still an hour, right? The behavior tree will keep running and it will keep checking. So it will fail every time it will arrive at wake up if the sunrise did not happen. There is still some time. So it will keep failing at the first stage and none of them will be executed because you just failed here. The sequence will go back and tell to root that, hey, I'm failed. Let's say you are here. You want to leave for home and your car is broken due to some reason. So it will fail. So remember, if any one of the tasks fails, sequence is considered as a failure. Otherwise, if everything is executed successfully, then it is considered as a success. Okay. So of course it is not going to happen. Something might not work. There can definitely be a situations. So we want our AI to make choices in that case. So for this, Unreal Engine gives you a selector. I'm just considering the exact example and we are building on this. And I will tell you how I arrived at this structure. But first, let's understand what selector does and how it provides you the choices feature. So let's say you start from root, then you come at a selector. The selector will first go to its leftmost task. Remember, selector will try to execute one of the tasks. And if any one of them succeeds, it will stop. That means it will not go further. It only needs to find one task that is successfully executed. So the selector will go. It will start from a sequence node. First, the sequence node will have a decorator on top of it, which says, are you at home? So if you are at home, then I will allow you to execute. Otherwise, I'll give a fail signal. So let's say you are at home. So it gave a successful signal and then we will check the first task. Again, there is a decorator that checks, are you sleeping? Because if you are not sleeping, waking up doesn't make sense. And if wake up fails, it will not go to this task anyway. So it makes sense to use a sequence task because getting ready is dependent on the wake up. Let's consider you are sleeping. So it will wake you up. it will give a positive signal. Sequence will say, okay, let's go further. We have a get ready. Let's execute it. You are ready now. So the character is ready and the sequence will say, okay, I executed all of my tasks successfully. So I'll give a green signal. Selector will say, okay, I'm done. I got one successful. So I'll go back to root and the game ends. Now behavior tree runs continuously. So if you come back to root by doing everything, then you will again start. So that means root will again call selector. Selector will go to sequence. It will say it is still at home. But now are you sleeping? No, you are ready. This will give a signal to sequence that one of the tasks failed, that is the wake up. The sequence will stop. It will say to selector, I am failed. So that means selector has to find another task that can succeed. So it will go in the order. And the second one is this selector. Now this selector is only allowed to get executed if you are not sleeping. So you are not sleeping because as soon as you wake up, you will make this parameter false. So this will be a true condition. So this selector will go further and it will talk to this selector. It will say, are you at home? Yes, you are at home. Let's consider that because you are still at home. You just got ready. So now you will go to this task and you will check, is your car okay? Is the weather okay? If it is so, then you will leave for your work. So let's consider everything is all right and you leave for the work. This will give a true signal. Selector will stop because it got one successful. It will go back to this selector. I am successful. So this selector will say, okay, I got a success, so I will go back. And this will say to this selector, I am successful because one of my child is successful. So I'll go back and this selector will go back to root. Now root will run again to selector. Then it will go here. Are you at home? No. Let's go here. Are you not sleeping? I'm not sleeping. So let's get inside. Are you at home? No, you are not at home. That means it will go further to check with this node. And are you at office? Yes. So let's execute the tasks of office. So considering it's a very simple AI, we say if you are at office, then you will first finish your work. That means roaming around, doing stuff, and then you will leave for home once the time is over. So you arrived at office by your car that you took from your home. So is this office time? Like, is it 9 to 5? We will say yes. So work at office. Let's say once you complete a report, it will give a successful message. It will go to this node. Remember, work at office means doing just one thing. Let's consider when we execute work at office, you just go to a table, do something, and then you get up. Then what sequence will get? Okay, this is successful. I'll check the next one. Is office time over? No. That means I again have to work at office. So we can randomly pick any task from this work at office thing. Okay. So the office time is not over. That means it gives a false. Sequence will say, oh, my one of the tasks is failed. So I'll go back to selector and I'll say I failed. So selector will say, okay, I don't have anyone. So that means I'm failed too because this failed. This one failed too. I'll go back to selector. Selector will say, okay, I'll go to the next one. It will check, are you at home? No. So we'll go back. All three tasks fail. Selector will say, oops, I'm a fail too. So it will go back to root. Now this will keep happening because you are at office and you are in the 9 to 5 time zone. Let's say that zone passed. The tree will keep running and it will keep arriving at work at office. Okay. You agree with me, right? You are not at home. You are not sleeping. You are at office. You will keep working because this is a office time. So this will return true and this will return false. So this task will keep failing and will result into entire failure of the tree. So it will always end up here. But now let's say if the time has passed. So this will fail and this will succeed. But will you arrive at this point? See, that is the problem with the sequence. So I kept this very intentionally so that you can understand where the sequence will fail. In such cases, the sequence fails. So whenever you have like a positive and a negative condition at the same time and you want to make a decision, you go for selector. Now just imagine, let's say it's 501 or let's say it's a 505. So selector will come here. It will go, are you at office? Yes. Is this office time? No. But you wanted to go here, but the sequence node stopped you. So you cannot rely on sequence in such case. So what you will do, you will replace this with selector as well. So let's edit it and I will call it selector. Okay, so that means if we choose this selector, then let's see what happens again. Are you at office? Yes. Is this office time? Yes. So you keep working. This will return success. This will return success. This will return success, and it will go back. Remember, selector will not move forward if it encounters one success. So let's say that now the office time is over. So you arrive at office again by traversing all the way from top to bottom. Now this will fail because it is not office time. So you will go further and you will check, okay, is this office time over? Yeah, that's why you came here. So you will leave for home immediately. So you leave for home, this will say success, 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 and success. Now once you get to your home, you will end up satisfying this condition. Now, are you sleeping? No. The sequence node will not go further. So it will result in 2 fail. Selector will say, oops, let's try another. Will come here. Are you not sleeping? Yeah, you are not sleeping. You just arrived at home. Are you at home? Yes, I am at home. So are you ready? Why am I ready? Okay, you are not ready. Let's say not going office. No, I'm not going office. So you'll play games? Of course not. So there is another condition required here, that is a time. Okay. So that means you want to check if it has passed the 9 to 5 timing. Okay. So you pass the 9 to 5 timing. So we will add evening here. Okay, so let's make a correction. So I wanted this to be an active exercise. So I intentionally removed 2 tasks so that I can communicate the issues and show you exactly how you make corrections, because it is easy to learn by making corrections. So we will say, okay, let's put time here. And now this will fail and the selector will go to here and it will say, yes, I'm at home. My time is greater than 9. So I need to sleep. So you will sleep. Now you'll go back. Are you at home? Yes. Are you sleeping? Yes. So wake up. Does that make sense? So this is how you create the structure. Let's start how we can build this tree on our own. First, you need to specify where we should be making choices and where we should focus on going with the flow. So first is the wake up task. I placed it. Now, do you want to get ready right after it? Yes. So I'll go for a sequence node in these two. Now, can I leave for work? No, there is a choice I have to make. What other choice can it be? Because if it is not ready, if my car is not okay, my weather is bad, in that case, I would like to have a different choice. So you play games. Okay, so these are the 2 choices I would like to choose. Now, once I leave for work, I would like to work at office. You keep working at office. But now, do you want to leave? Yes, I want to leave right after it. But this task can be a loop or it can be one-time job. Okay, it can be a big job that takes 8 hours. This task can take its own time. Every task can take its own sweet time. Remember that. So either you can take the entire time in this task or you can create a loop where you randomly pick jobs. So if it's a loop, then the tree will keep calling itself again and again and the situations will lead you here. So let's say I want a loop. That means my tree will keep running. I'll do and randomly pick the job. So, okay. Then I'll want to leave once the time is over. And once you leave, you want to sleep. So let's keep the sleep aside. And this one is a part of sequence. So we'll put a sequence. We have to make a choice. Put a selector. Now, again, you want to make a choice. So we will go for a selector again. Then out of these 2, you again are going to make a choice, because either you can leave for work or play games. That is happening at home and these are happening at office. That decides in which direction to go based on are you at home or you are at office. Then you will again pick a choice, because this is a morning time and this is a post morning time. Okay, when you wake up. So this is how you construct the tree. And then you are well aware of the sleep task. That is an individual task. So this is how you construct the tree. First, you list down your task on a rough paper or a whiteboard and then decide how do you want to place the logic. Don't straight away start with the behavior tree. And of course, if you feel that space and canvas and dragging around stuff over there much better than doing it on paper, for sure, go for it. Oh, by the way, service will run somewhere here because everyone needs to access the time. So we will create service here and it will update time in your Blackboard, in your memory. So I'll tell you when we get there, but the idea is there are tasks, there are decorators, okay, then there is a service that keep track of time, and then there is a Blackboard which saves all the data, that whether you left for work, you are playing game, what task you are doing, do you have a car, and everything. So that's it for this video. I hope you enjoyed it. Do let me know if you have any suggestions, questions, or doubts in the comment section. And in the next episode, we are surely going to start the technical implementation of the behavior tree. And the target of next video is to build a companions movement behavior in the behavior tree. So we will be ideally targeting Atreus from God of War. So if you look at him in the gameplay, there are two common behaviors. One is that he follow you around and sometimes he escorts Kratos to different destinations at a certain game point. And another behavior is the tailing or stalking, which is inspired from Assassin's Creed 3, where you can tail your enemies, or that can happen vice versa. So there are three behaviors that we are going to have in your AI. That is, first, they can follow you. Second, they can escort you out from a specific point to another destination. And the third one is for enemy perspective, that is stalking or tailing the next person, which can further lead to eavesdropping feature in your game as well. So this is the companion behavior part that we are going to implement in the behavior tree. And after that, I'll show you the same implementation in the state tree, and then you can understand and finalize what is it that you want to choose for different game situations. And of course, it will be modular. So that means they can be attached or can be adapted by any AI, in fact, your player as well. So if you like my work and you want to support me, the Patreon link is in the description. Please do reach out on Discord before buying any membership. And like the video, share it with your friends, subscribe to the channel, and I'll see you in the next episode. Till then, take care. Bye bye.